Today we're going to talk about exponents and how we can use them and how they work to make sure we can move forward in the rest of this chapter. A power is a product of repeated factors. The base of the power is the repeated factor, the number that is being multiplied over and over again. So for the example that we can see right here, this was the base. That is the number that's being multiplied again and again and again. The exponent of a power indicates the number of times the base is used as a factor. Basically, in other words, how many times you are multiplying it together. So in the case of the example that's right here, the power is the whole 1/2 to the 5th. The exponent is the 5th. That tells me how many of the 1/2s are going to be multiplied together. So we'll see 1, 2, 3, 4, 5. The base being the 1/2 is why this is the factor that's multiplied 5 times. So then at this point you would just multiply out 1/2 times 1/2 times 1/2 times 1/2 times 1/2. We're not going to worry about right now what that actually is worth. It's more about understanding how the exponent works. Exponents can be tricky, and it's really important that we understand how they work. So an exponent only affects, and it's important that we see it only affects what it is right next to. So for example, we can see here -2 to the 4th and -2 to the 4th. Well, when I say those both out loud, they sound like the exact same thing. But notice the one on the right has the parentheses around the -2. So a couple of things to keep in mind. So first, the bases from what we just learned up above is the number that's being multiplied over and over and over again. Well, think about this for a second and make sure we understand this. For this first example, the base is actually just the 2. And I know it looks like it should be a -2, but in the exponent world, the base is the thing that the exponent is affecting is the very first thing it hits. So this is actually 2 times 2 times 2 times 2, which is 4 2's, but also times that negative out in front, which is a -1, to make my answer -16. Now, notice the second one. So if I look at this one, the base this time is actually a -2. The reason I know that is because the 4 on the outside, the very first thing it hits is actually the parentheses. And we know that parentheses always come in pairs, which means everything on the inside is going to be the base that the 4 affects. So in this case, the second one is a -2 base times -2 times -2 times -2, which means my answer is now not a -16, but 4 negatives become +16. So a much different answer for these two. The -2 to the 4th without the parentheses becomes a -16. The -2 inside the parentheses to the 4th is a +16. It's really important that we understand that. We're going to see lots of complicated things as we go forward this year and definitely more in high school. And you really need to understand that when you're doing your exponent work. It's very easy to think -2 to the 4th right away, say that the answer is 16 for both of these, and one of them is much different. So next we want to talk about how to write a product using the exponents. So as we just talked about up above, if I have a power that we're trying to write, the way we wrote it up top was we write the base. The base in this case is -7 in parentheses, because those are in parentheses. And then the exponent is how many times we are multiplying that number. Well, if I look at this number, I see 3 -7's. So this would be -7 to the 3rd. Now in this case, it really wouldn't matter if you had those parentheses or not, because -7 to the 3rd with parentheses or -7 to the 3rd without them would still be a negative answer. But it's just a good habit to get into that when you see -7 within the parentheses, you include them. So looking at the next one. So again, we actually have two different bases happening here. We see pi and we see r. So let's just take each one of them separately. So if I look at the first one, I have a base of pi. How many of those factors of pi do I have within this product? Well, I can see 2 of them, so it is pi squared. Then I move on to the second base, which is r. And if I was to write the r base, how many of those factors are being multiplied together? Well, I see r times r times r, which means the exponent is to the third. What you don't want to do is mix this together and try to make it pi r to the fifth. It's definitely not that, because we don't see 5 pi's, we don't see 5 of the r's. Each of those being multiplied together can go with as an exponent for that factor. There are 2 different factors that go together, so pi squared r cubed, or pi to the second r to the third, would be my answer for that. Next, we're asked to evaluate. So when I see this word evaluate, that basically means we want an answer this time. We want to know what is this value, not just how do I write it out expanded with exponents like we did in A and B from example 1. So again, looking at this first one, I see -2 is my base times itself times itself times itself. 4 of them multiplied together. The even number of negatives makes each negative pair up in multiplication to become positive. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And remember, just like we've talked about in grade 7 when you also did some exponent work, -2 to the fourth does not mean -2 times 4. It is -2 times -2 times -2 times -2. And then, just like we already kind of went through this example up above, -2 to the fourth very much sounds the same if I was to say them out loud. But in this case, again, we see that my base here is not -2. It's actually a +2, because that's the first thing the 4 hits. There are no parentheses there. So if I was to write this one out, it would be -1 times 2 times 2 times 2 times 2. So this time, 2 times 2 is 4, times 2 is 8, times 2 is 16, but times -1, that's where we got that -16. Now, looking down below, I know it's kind of hard to see it here on the picture, but this is actually -1/6 raised to the third power. Okay, so again, the very first thing that this exponent hits is parentheses, which does mean that the entire -1/6 is the base. So if I was to expand this out, it would be -1/6 times -1/6 times -1/6, and we'll put all those in parentheses to make sure we don't lose any of those negatives. And again, when you multiply our fractions, you just have to multiply straight across the numerator. 1 times 1 times 1 is 1. Multiply all the way across the denominator. Again, it's not 6 times 3, it's 6 times 6, which is 36, times another 6, which is going to be 216. And a negative times negative times negative makes this answer -1/216. And then moving on to the last one, we have -5 to the 4. Again, the first question you want to ask yourself is, what does the exponent affect? It only affects the number 5. Our base is, again, just the 5 because there are no parentheses. And so if I write out my 4 5s and I have the -1 out in front, then I can look at 5 times 5 is 25, times another 5 is 125, times one more 25 is a -625. So again, the word evaluate is when you actually do want to see the answer done out. If they just say leave it as something with exponents, you just leave it as the base with the exponent that you're looking for. So now, using our order of operations. So remember, if we go back to our order of operations, if we think GEMDAS, remember our first G stands for groupings. Remember, the E stands for exponents. So when you are thinking of your order of operations, it's important to think groupings or parentheses, Then we see our exponents. Remember, multiplying and dividing would be the next step. They are equals to each other. And then addition, subtraction are our last, which are also equal to each other. But this is the exponent part that you need to think about. Okay, so evaluating expressions. So this first one, we have 3 plus 2 times 3 to the 4th. Well, I don't have any groupings, so I don't need to worry about that. But what I do see is the very first piece that I need to do is I need to do this 3 to the 4th. So 3 to the 4th. 3 is the base. There are 4 of them. And if I was to multiply 3 times 3, I get 9. Times 3 is 27. Times 3 is 81. And again, don't make the mistake of saying 3 to the 4th is 12. It is 3 times 3 times 3 times 3. So again, bring down all the information. We have figured this part out now. It's 81. I look back at my order of operations and say, okay, what's next? Well, I see addition and I see multiplication. Well, multiplication would be the next thing if I'm looking at GenGas. So I would focus on 2 times 81, which is 162. And then I can finally do this addition out in front to get 165. For number B, letter B, I have 2 different bases that have to be done with their exponents first. Here's where people start to do things a little bit too quickly and try to do things a little bit too fast, and I make silly mistakes. So 3 squared, or 3 to the second. 3 to the squared, or 3 to the second, remember, is 3 times 3, which is 9, not 6. Then I would be subtracting 8 squared. Well, again, 8 squared is not 8 times 2, it is 8 times 8. So it is now a 64, not 16. And then adding 2. Okay, then I move on to the next. Well, I see addition, subtraction, but remember, we would be doing subtraction first in this case, because if you have them both, you would focus on left to right. Okay, so 9 minus 64. 9 minus 64 is going to give me negative 55. Oh, yikes, that's not a good 6 or 5 for that matter, and it should be a 5. And then I can add 2 to that to get negative 53. Okay? Moving on to the next one. If I move on to the next one, I'm going to get 2 to the 5th would be the very first thing that I would do. So thinking this out, 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. 1 more times 2 is now 32. So I'll bring down all my numbers here. 9 minus 32 times 0.5. Don't fall into the trap of doing 9 minus 32. We focus on this multiplication, which gives me 32 times 1/2, really, is now 9 minus 16. 9 minus 16 I can finally do to get a negative 7. And then lastly, so we see this absolute value bars. Remember, the absolute value is the distance from 0. Distance is always done as a positive. So no matter how far I am, either left to this from 0 or right from 0, it's a positive distance. But it is a grouping symbol. So I'm basically going to focus on everything on the inside, and then I would do the operation last. So I'm going to keep these parentheses for a second. So negative 3 to the 0 power. I'm sorry, negative 3 to the 3rd power. I know it's hard to tell there, but that should be to the 3rd. So negative 3 to the 3rd. Negative 3 to the 3rd would be, notice there are no parentheses around that base of a 3. So really, that is going to look like negative 1 times 3, 3 times. 3 times 3 is 9, times 3 is 27, and it's a negative 27. So the negative 3 to the 3rd is going to be negative 27, and I bring in the plus 27. Well, negative 27 plus positive 27 is a 0. And what is the absolute value from 0? It actually is 0. So my answer is just going to be a simple 0 there to give me my answer evaluated for that expression. Our last example is trying to look at a real life situation. It's missing a little bit in here, so I want to add the equation that should be situated right into here as we're talking. The annual profit, thousands of dollars, so we want to remember that when we get to the end of this, earned by a technology company X years after opening is represented by the following equation. P equals 0.1x cubed plus 3. Okay, we didn't come up with that. We don't really need to know where all those numbers are coming from. They're giving us the equation. How much more profit is earned in year 5 than in year 4? Well, we got to think about how we get to this. So we can find the P, or profit, from any of these years by knowing what year we are and using the formula. So let's use the formula to figure out how much we made in year 4, for example. So at the moment, we don't know what we made in year 4 or in year 5 or in year 1 or 2 without plugging the numbers in and using the formula. So if I want to know year 4, I'm just going to plug in my formula. I don't know the profit, but I do know the 0.1. I now know that it's year 4 we're looking for, raised to the 3rd power, and plus 3. So now with my order of operations, I can complete that side. The first thing I would focus on is the 4 to the 3rd. Remember, the 4 is going to get the 3 only because that 3 is hitting just the 4, not the 0.1. So the 0.1 is going to come down and wait for a minute. So what is 4 to the 3rd? Well, it's 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is now 64. And then I would be adding 3. Then again, when I look down to my next order of operations, now I would focus on this multiplication. 64 times 0.1 is going, 0.1. Yeah, 0.1 is going to be 6.4. And then I would bring down the plus 3. Then I can do that last piece together, which is going to give me, remember, I think decimals, it is going to be 9.4. So then let's focus on, well, what about year 5 then? Those are the 2 years we're comparing. So just like in the last one, we're going to now enter 0.1. Now we're looking at year 5, so my x is now 5. And again, through order of operations, 0.1, the 5 is the base. 5 times 5 times 5, which is 125, plus the 3. Then I can focus on P equals 0.1 times 125, which is 12.5 plus the 3. And then my final answer here would be 15.5. So again, what do these numbers mean? Well, way back up at the top, we were told that the P is in thousands of dollars. So we have to kind of work this out and finalize this answer. So really, we aren't making a profit of $9.4. We're making a profit of $9,400 for year 4 and $15,500 for year 5. And again, the answer was looking for how much more profit. Basically, it means subtract the two numbers. So 15,500 minus 9,400. Year 5 had $6,100 more in profit. So this is just the introductory lesson for this whole chapter. It's important that we understand it. It's a pretty basic section, but it's really important that we get it, we understand it. We'll do a little bit of work on it before we move on to the next part about putting together operations of these different things. So really focus on this and the activity that you are given. And if you have any questions, please make sure you are checking in.